Hey, physical science, it's Tuesday, April 28th. Let's skip chapter 17 and go straight to 18. I'm on page 552. 552, and from now on, you're going to need one of these every time we talk. So where are you going to get that? It's either inside the back jacket. You're going to keep flipping back there and referring to it, or page 500, I believe it was, in a previous chapter. Let's go ahead and combine elements. We talked about atoms of elements in the chapter 16. Now let's put them together. Atoms are like letters and formulas are like words. And so what is the formula for H2O, for example? Is it H2O1? What does that mean? It means you got two atoms of hydrogen and one atom of oxygen held together by some bonds that we call covalent bonds. Those are sharing electrons that hold these atoms together. And we're going to talk more about that as we go along. So what are these called? That's called a compound. I thought that was a formula. Yeah, it's a formula which represents a compound. And a compound is a mixture of elements that are held together by bonds. And the materials that go into making the compound have different unique properties from the compound itself. For example, if I wanted to make water, I would take hydrogen gas and I'd combine it with oxygen gas, and I would form water. And this is a gas, I put a G there, and that's a gas, I put a G. Gas at room temperature, of course, that can be liquefied, and so can that. That can even be frozen solid, if you get it cold enough. Anyway, this is a gas initially, but then as soon as it forms a gas, it becomes a liquid because it forms a really hot gas, which condenses and releases energy. It forms a liquid by condensation. Okay, so the hydrogen is a gas. It's a different properties than the water, it's liquid water itself. Okay, and look on the bottom of 552, you can see copper, pot, and sulfur. It's a yellow powder. If you burn sulfur, it's going to be, those stink bombs that you've smelled in the hallway. Not really, but they can be. If you go out to Yellowstone, that stuff bubbles up from the earth because magma in the earth is carrying sulfur. It's molten rock, and anyway, so the sulfur gets inside the coal, and then the coal is burned in a industry, and then it gets up into the air, and it's called sulfur dioxide or sulfur trioxide, and it creates this acid rain. Well, anyway, part of the deal is that sulfur dioxide gas, sulfur in the air, and then the oxygen in the air, and then the copper of the Statue of Liberty, you see that on 552, becomes green. And it turns, it's called corrosion, and we call it a patina. Now, when iron rusts, that's called corrosion also, iron oxide, and it will break down the iron. But if the copper gets covered with a patina, it actually protects the copper. So it's just the way chemicals work in nature. Page 553, you can see that potassium is up there. Potassium is in the alkali metals. It's right here. And the first group is called alkali. They're soft. They can be cut with a knife, but they still got shininess called luster because they're metals. And potassium combines with this iodine. Iodine is normally a solid flake at room temperature, but when you put a little heat on it, it turns into that lovely lavender vapor. Anyway, they combine together, potassium and iodine, and form this powder called potassium iodide, Ki. All right, and then the symbol is, these are all symbols, and you put them together and you make words called chemical formulas. A chemical formula on page 553 shows what elements in a compound contains and the exact number of the atoms of each element that in a unit of that compound. Subscript means written below. You can see that H2O has a subscript 2 and an invisible subscript 1. If it's not written there next to the atom, it's assumed it would be 1. And this has a subscript 2 and a 1, 2 there, and 2 there. Now, why are some elements like zinc, you can write those without a 2, And some elements, you have to write them as a 2 when they're by themselves. Well, those are diatomic elements, and zinc is not. There are only 7 of those on the periodic table. They happen to be hydrogen, and then around the corner over here, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And those need 2 atoms of that element in order to form a molecule. And it doesn't exist alone, but all the other elements, you can write them as 1 atom of that element. Does that make any sense? So there are certain elements, there are 7 of them, that need a buddy. If they have a buddy, like oxygen has a buddy called hydrogen, then you can have 1 atom of it. Otherwise, if it's by itself, you got to have 2. And anyway, all the rest of them you can write alone. And those chemical formulas are made up of atoms of elements. And the subscript means written below. And if there's no subscript, it means a 1. Look on page 553, table 1. I'd like for you to see that sand is silicon dioxide, SiO2. Milk is milk of magnesia, which is a kind of a laxative in your medicine cabinet, is magnesium hydroxide, Mg parentheses OH parentheses 2, and you'll know what the OH stands for later. Cane sugar, sucrose, is C12H22O11, that's table sugar. Lime is calcium oxide, CaO, we used to put that on the baseball field. Vinegar is acetic acid, and it's called chiku. That's what I call it, CH3COOH. And laughing gas is dinitrogen oxide, N2O. Grain alcohol is ethanol. Yeah, I always do that. Grain alcohol is C2H5OH. And battery acid is sulfuric acid, H2SO4. Stomach acid, that's really in your stomach. God put it there to help you metabolize, break down your food, is hydrochloric acid, HCl. I've already talked about that. Oh, no, I haven't. Talking about HCl, let's put together a compound. We've got to do that. This is where chemistry becomes fun, except we're not in our classroom. And I'm very limited on what I have at home. I have a few meager things. I've got some hydrochloric acid here, HCl. It's called muriatic acid down at Lowe's. Anyway, they use it to clean up masonry and that kind of things. Okay, and I've also got some zinc. Some mossy zinc. See, doesn't it look mossy? Of course it does. All right, so that zinc we're going to put in a test tube. And all right, you've suffered with me for 7 minutes. Wait, that's 5, 6, 8 minutes. Wow. Here we go. So we got some zinc in there, Zn, and we're going to put some hydrochloric acid on it. And you're going to see it liberate the hydrogen. In other words, it's going to release the hydrogen from the acid. So let me write that down before I do it. So we've got some zinc solid, and we've got some hydrochloric acid aqueous. That means it's dissolved in water. Okay, and what we're going to get is zinc is going to combine with chlorine to form zinc chloride. That's a C. There, let me make it a better one. And an L. And that's going to be a solid. And what are you going to release? You're going to release hydrogen. We're going to put plus H2. Don't forget, it's gas. Don't forget, it's one of those diatomic elements. All right, so zinc solid plus hydrochloric acid, aqueous, yields zinc chloride solid and hydrogen gas. Okay, that's what you're going to see before your very beady eyes. We're going to start out with elemental zinc. Say elemental. Now you know. That sounds pretty chemistry-ish. And we're going to put some hydrochloric acid in here, full strength, 12 molar. I've got all my safety equipment on. Of course, you can see that. It's liberating gas like crazy. That's an evidence of a chemical change. Okay, and we're going to go ahead, and by the way, it's really hot. Releases a lot of energy when it does that. Okay, and now we're going to go ahead and we're going to take some of that and harvest it. We're going to put this big test tube over the top, And since hydrogen is lighter than air, it'll go up into that big test tube and it'll gather at the top of that test tube. And it won't get out unless some of it diffuses. It'll be pretty slow, however. So I'll be able to pop it because hydrogen is combustible. Say combustible. Hydrogen is combustible. That's why the Hindenburg blew up, is because hydrogen is combustible. Okay, and that was a great big old blimp of the Zeppelin class made by big and bad Adolf Hitler. Of course, you've heard of him. Back in the day. All right, so here we go. We're going to go ahead and we're going to pop this. Yeah, that was nice. Let's gather up some more. And while we're gathering up some more, I'm going to tell you that inside here you can see water droplets. See how foggy it looks? It was initially water vapor, but then it turned into water droplets. I'm going to try to salvage this flame. Nope, I didn't salvage it. So I'll pop it again. Think I've gotten any more hydrogen in there? Let's see if we've gotten any more hydrogen in there. Okay. Come on, baby. Woo! Whoa, I guess we got it that time. Yeah, you can see where all those rings are inside there. That hydrogen that turned into water, and then the water oscillated back and forth, and it deposited itself and left it down as water droplets as rings. Water vapor. Okay, so there you have it. That's a chemical reaction, and that is a chemical formula. Oh, do you want to see the zinc chloride? Here's the zinc chloride. See that black stuff on the bottom? Let me turn it. It isn't silvery anymore. You can't see it, I guess, as much. But anyway, I can see it real clearly. It's nice and black. All right, and so it's got different properties than the zinc had to begin with. See ya.